Okay, good morning everyone. Okay, Shanki. All right, Caroline having technical issue now. All right. So this please click the link and also enter the code. Okay, as usual. Okay, so today is already 35. So who's it who still didn't join the class point? Or anyone cannot join? Yeah, I'm saying link now. Okay. So everyone already joined the class point. Okay, thank you. All right, so today we continue on interference of wave, right? So in diagram 1.5.1, right, shows a water wave when two stones are thrown in the water. So if you throw one stone, okay, it will produce one circular wave, right? But let's say if you throw two stones, okay, so that will produce two circular wave, right? That some of the wave, okay, some of the part of the wave will overlap with each other. So example like this, okay. So let's say if I throw two stones here, so this one will produce a circular wave, right? And also for this one also, it will produce the circular wave. So you can see at the middle here, right, there is a wave that overlap with each other. Okay, so this is what we call it as the interference. Okay, so let's see the video. Okay, so this is the example of the interference. You can see there is a part here, okay, that the wave is overlap with each other. Okay, so this is the example of the interference of wave. Okay. What is superposition?
Hi, it's Mr. Anderson, and this is AP Physics Essentials video 113. It's on wave superposition. What does that mean? When waves interact with each other, they
Okay, so they say now we use a slinky spring, right, to describe the wave interference. Okay, so you have to know there must be a two source of wave, right? So for this one, they use a slinky spring. So how they produce the two source of wave? Okay, so the first one, they oscillate the slinky spring, okay, from the left and others from the right. So means they will produce two wave, okay, they will produce two wave like this. Okay, one will move to the right and one will move to the left. Okay, so at the middle, okay, at the middle, okay, so let's see what happened at the middle here. Okay, what happened to the wave, right?
can either build each other up or tear each other down. And so let's watch this wave right here. We're sending two waves. These are transverse waves towards each other. And so what's going to happen when they meet? What's going to happen at that point where the slinkies are connected? Well, there will be superposition. They'll come together and we're going to add the values that they had before. And so watch what happens when they come together.
Okay, so you can see here the first wave come from the left, and the third one come from the right. So at the middle there, okay, they will overlap each other. So let's compare the amplitude. Okay, so you can see the amplitude at the middle here when they overlap, okay, is twice than before. So let's say if I put a number, okay, if I put a number, all right, so the amplitude for the wave that comes from the left is 1 cm. So let's say the amplitude is 1 cm. Okay, and if come from the right, okay, is also 1 cm. So what happened at the middle here, okay, so there will be twice, there is 2 cm, right? 1 cm plus 1 cm is 2 cm. So this is actually the principle of superposition. Okay, you just sum up, the amplitude, right? The amplitude of the wave, okay? And this one, okay, we call it as the constructive interference, okay? Constructive interference. Okay, so let's see the video again. So there is a two wave, okay? You can see there are two waves. Okay, the first one come from the left and the other come from the right. Okay, so what happened at the middle here when they overlap with each other? Okay, so they will use the principle of superposition. Okay, the one that I mentioned just now. Okay, 1 cm from the left and 1 cm from the right. So at the middle here, there will become 2 cm. So this is actually the principle of superposition.
That they had before. And so watch what happens when they
see. Oh, sorry.
They're built waves. These are transverse waves towards each other. What's going to happen at that point will be come together. Had before happens when they come together.
Okay, let me. Right. So you can see the amplitude become twice. Okay, as before. Okay, and another thing. Okay, after they already collide. After they already overlap at the middle here. Okay, the wave that move to the left, we continue to move to the left, right? After they overlap, the one that moved to the left, it will continue move to the left, okay? And the other one who moved to the right, okay, after the overlap, it will move to the right, okay? So that's another thing that you have to know. So this is called as the constructive interference, and actually the constructive interference, they use the principle of superposition, okay, to find the amplitude, okay, at the middle here.
Together, we get one giant wave. Now it's hard to watch that and figure out, did the waves hit each other and bounce off, or did they go through each other? So this one might help a little bit. We've now got a wave coming from the left that's on the top.
Okay, so now, okay, from the left is actually the crest, right? So just now what you see is crest meet with the crest. Okay, then you can see there is a crest also, but the amplitude is twice, okay, than before. And for this one, okay, is crest meet with the throat. So what will happen at the middle here? Okay, and you have to notice what happened after the overlap, what will happen to the wave direction, okay?
And from the right, that's on the bottom. And so what's going to happen here? Well, you've probably figured out that they'll cancel each other out. And so if you watch that point in the middle, it won't move up or down very much at all. But watch what happens to those waves after they hit. The one on the bottom continues to the left on the bottom.
Okay, so you can see at the middle here, at the middle of the sinky spring, okay, the sinky spring is not move, so doesn't move so much, right? So that means, okay, that is the crest, okay, meet with the throat, okay, and this one, if you use the wave of, if you use the principle of superposition, okay, so the resultant wave will become like this. Okay, when the crest meet with the throat. So at the middle here, you can see the sinky spring doesn't move that much. And you can notice, right? You can notice the direction of the wave there, right? The direction of the wave just now, this one is up, this one is down, okay? But after it overlap with each other, so you can see the crest continue move to the right, and the throat move to the left. Okay, so means after the overlap, okay, they will continue to move with its original direction. And this one, we call it as a destructive interference. And this one is the constructive interference. And this one is a destructive. Okay. And another thing for the constructive interference, it does not only like crest meet crest, okay, that will produce the constructive interference. So let's say if throw meet with the throw also, okay, let's say this one is a negative A and this one is a negative A. Okay, by using the principle of superposition, right, so you will get negative 2A. So this one is also the constructive interference, right? So actually when crest meet crest, or when the crest meet the, when the throw meet with the throw, and they will produce the constructive interference. And let's say for the crest meet with the throw, they will produce the destructive interference. Okay.
Bottom continues to the left on the bottom, and the one on the right continues on the right. And so when waves interact, they don't bounce off each other, they will move right through each other. But as they move through each other, they will interfere with one another. And that interference can be constructive. In other words, when two waves come at each other, we build one giant wave. Or it can be destructive. In other words, they cancel each other out. But superposition is that idea that when they're together, we add those two values together. And we could do that through experimentation, or we can make sure that applies through experimentation. And so if we look at this, now we're adding a transverse.
Okay. All right, so that is the interference, okay, to show how, actually the concept of interference by using the slinky spring, right? So actually interference, they can occur in the water wave, okay, and light and also sound. So now what we see for the water wave first. Okay, so observing the principle of superposition. So this one actually you already see by using the spring slinky, the slinky spring, okay, on the video just now, right? So I just move on to the next one. Okay, so you can see when the two pulses met, they overlap, then continue to move in the original direction. Okay, so when two pulses met, okay, and they overlap, okay, then after that, they will continue to move to their original direction.
Tak masuk dalam video ni. Sekejap. Satu, tiga. Tiga ikut. Satu, dua, tiga.
So you can see they produce the giant wave, okay, at the middle here. So this is actually the constructive interference. Alright, so the next one, you have to compare the amplitude of the wave after they met with the amplitude of the single wave, okay, before both wave pulses met. So the amplitude, right, the amplitude of the wave after they met is twice time higher. So just now I already said, let's say this is 1 cm, right, the one that come from the left is 1 cm, and the wave come from the right is 1 cm, okay, their amplitude. So 1 plus 1 is 2 cm, so it become double. Right, so we use the principle of superposition, okay, to describe that. So write an equation to relate both amplitude of two pulses when they met with the resultant amplitude after they met together. Okay, so A plus A is 2A, like 1 plus 1 is 2. Okay, combining the two overlapping wave can be explained by the principle of superposition, right? So when the two waves interfered, so this is actually what does the principle of superposition means. So they say they ask you what is the meaning of the principle of superposition. They ask you to state the principle of superposition. So actually, when the two waves interfered, right? So the resulting displacement, okay, of the medium at any location is the algebraic sum of the displacement of the individual wave. Right, so this means the individual wave. So just now, like I said, this one is 1 cm, come from the left is 1 cm, all right, and the other one, okay, come from the right is also 1 cm. So if you want to find the resulting displacement here, so you just need to add the, okay, the algebraic sum, okay, so means 1 plus 1, so then it will become 2 cm. So this is actually the principle of superposition. Okay, so the resulting displacement, okay, at any location is the algebraic sum of the displacement of the individual wave. So this is the example. Okay, A1 plus A2 is actually equals to A3. Okay, when they overlap with each other, so at the middle there, so you become A3. Okay, so when two waves met, okay, they superpose or combine at particular point. So this one come from the left, this one come from the right. So at the middle here, there will overlap. Okay, so this one we call it as the interference. Okay, so the wave are said to interfere. So this phenomenon is called interference. So what is the interference of wave? So interference of wave is the superposition, okay, of two waves originating from two coherent source. All right. So it means the superposition of two waves. So let's say you have I have this one, right? So this is two wave, okay, two wave. Then they will overlap, okay, or combine with each other, okay, and produce the interference. So interference is the superposition of two waves originating from two coherent source. So what is actually the coherent source mean? So the coherent source is actually the meaning is must have the same wavelength. So both of the source must have the same wavelength, okay, and also same frequency and constant phase, right? So that's the meaning of true coherent source. So if let's say you use two waves, so these two waves must have the same wavelength, same frequency, and same constant phase, then the interference can occur, right? So this is the okay, this is the let's say if the sources is one, you use another wavelength. Let's say this is 6 cm, another one is 8 cm. So that is not the interference. So they must come from the two coherent source, right? And you can see as this one, this is the constructive interference. So this is example. So let's say throw, okay. So that will produce double amplitude, okay. And this is called as the constructive interference. And this one if crest meet crest, so that will produce the constructive interference, but the amplitude is double. Okay, and for this one, this is a destructive interference. So this is throw meet with the crest, okay, at this part, okay. So that will produce the destructive. And this one is a crest meet with the throw, and also they will produce the destructive. Okay, so this is how you, if they say they ask you to draw, okay, for destructive, you just draw a line like this. Okay, so this one we already discussed. Okay, for negative A plus negative A, it will become negative 2A. Okay, this is the example of the constructive interference, and this one is the resultant amplitude is 0. So this is the destructive interference. Okay, so this one is actually what I just discussed just now about the two coherent sources. So it must come from the same wavelength, same frequency, and constant phase difference. So that's the meaning of the coherent, right? And this is the example of the interference. So this is for interference of water wave. Okay, they use a two deepest, okay, to produce. Okay, after this I will show a video, right? And this one is the interference of light. Okay, they use a double slit, okay, to produce the interference of light. If one slit is diffraction, right? If the laser, okay, pass through one slit, okay, so it produce diffraction. But this one is a double slit. So if double slit means this one is the interference. Okay, so interference of light. And another one is the interference of sound. Okay, it comes from the two speakers. Okay, so the one or each of the speakers will produce their own sound wave. And after that, they will overlap with each other. Okay, some of the part of the wave will overlap with each other. So that produce the interference of sound. Okay, so this one also we already discussed. right? So let's see the difference, okay, between the constructive interference and destructive interference, okay, for water wave, right? So let's see if I put the object, okay, at the part where the constructive interference occur. So what happened to the object? Okay, so the object will move up and down. Okay, because since there will be a constructive interference, so it will move up and down. Okay, let's see if I put the object, okay, where the destructive interference occur. So the water will become calm, or see the object will not move. Okay, the object will not move. Okay, because the water is calm, there is a destructive interference occur there. And then the next one, they say for the light. Okay, this is for the water. Okay, for the light, okay, for the constructive interference, you can see there is a bright and dark fringes there, right? So the bright fringes, okay, is actually the constructive interference. Okay, and while the destructive interference is the dark fringes. Okay, that is for the light. Okay, how you can recognize which one is the constructive, which one is the destructive. Okay, for the light, the bright one is the constructive, the dark one is the destructive. Okay, how about the sound? Okay, for the sound where the constructive interference occur, so the sound will produce loud. Okay, but for the destructive, the sound produced is soft sound. Okay, so that's how you compare for the constructive and destructive interference, okay, for each type of the wave. So light wave, water wave, and also sound wave. Okay, the next one we see to we move on to the anti-node. Okay, but sometimes in the questions they didn't mention constructive interference. Okay, they use anti-node. Okay, so when they mention about the anti-node, so you know already at that point, okay, that is the constructive interference occur. Okay, so at the point where the constructive interference occur, we call it as the anti-node. Okay, anti-node. So if they mention to you, okay, this is where the anti-node, okay, this is the point for the anti-node. So you already know, oh, this one is the constructive interference. But let's say if they mention to you for node, okay, and for node is the point where the destructive interference occur. So if the question mentioned this is the point A is the node, so you already know, oh, that one is a destructive interference. Okay, then how about the anti-node line? Okay, anti-node line is where you connect all the constructive interference, all the point where the constructive interference occur. You connected all the point and it will become one line. So that line we call it as the anti-node. Okay, later I will show you how. Okay, and another one is a node. Okay, the node is actually a line which connect all the node points. Means the node means all the destructive interference. Okay, you connected all the point and it will become one line. That line we call it as a node line. Right, so I will explain it for a moment. That's a diagram actually. Okay, like this. Yeah, this one. Okay, so remember just now anti-node is what? Anti-node is a constructive interference. Okay. Anti-node is a constructive interference. Okay, so let's label where does the constructive interference occur. So remember it's crest, mid-crest, or throw, mid-throw. So the darker one, the darker line, okay, that is the crest, okay, while the one the less dark one is actually the throw. Okay, so you already know crest, mid-crest, or throw, mid-throw will produce the constructive. So here they produce the constructive. Okay, crest, mid-crest, and this one is throw, mid-throw, also the constructive, and also this one also constructive. Okay, so when I connected all these three lines together, okay, all this is a constructive. Okay, that will produce the anti-nodal line. So this is called as the anti-nodal line, right? Where I connected all the constructive interference, right? And for this one also is the same. Okay, this one also constructive, throw meet with the throw, this one crest meet with the crest, throw meet with the throw, crest meet the crest. So this one also constructive. So when I connected all of it, that will produce the anti-nodal line. Okay, so you can see below here the diagram. So all of this is the constructive. So I just connected all of it, that will produce the anti-nodal line. So how about the nodes, okay, the nodal line? Okay, so we connect all the destructive interference. And you already know that nodes is actually the destructive interference. So crest meet with the throat. So this is the example. Okay, so you can see here this one is the crest meet with the throat, the blue dots there. Okay, and this one also crest meet with throat, this one also crest meet with the throat, this one also crest meet with the throat. So all of it is a destructive. So I just underline it like this. Right, so you can see, okay, the line is called as a nodal line. Okay, I connected all the destructive interference in one line. Okay, one straight line. So this one is the nodal line. So we call it as the nodal line. So same like this also. Alright, this is also destructive, 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 and destructive. So I try to connect all the line here, all the destructive interference here. So that will produce a line that we call it as a nodal lines. Okay, so I hope you understand what is the anti-nodal line and also the nodal line. Okay, we go back to the previous slide. Okay, so this one is actually the experiment, right? To see the interference of interference pattern of water wave. So I have a video for you. Okay, this one is in they use a ripple tank. Okay, so this is the interference. Alright, so you can see there is a 2 dipper here. So the 2 dipper, okay, will vibrate. Okay, okay, and then they produce the 2 wave. Okay, and at this part, you can see there is a interference occur. Okay, and remember at the bright one is a constructive, while the dark one is a destructive. Okay, so this one is actually crest meet with the crest. Remember, you already learned that crest they produce the bright one. Okay, the bright color, the bright wave. Okay, while the throw will produce the dark one. Okay, so here at the bright one, this is the crest meet with the crest actually. Okay, so this is the interference. Okay, they use a 2 dipper to produce the 2 source of water wave. Right? Okay. So we continue. Okay, so that's the experiment for the interference. All right, the next one, it says here, compare the frequency. So remember, for you to produce the interference, okay, we have to use the 2 coherent source, right? So means 2 coherent source, okay, we already learned what does it mean by 2 coherent source, same frequency, same wavelength, okay, and the constant, same constant phase difference. Okay, so means here, if they ask you to compare the frequency must be same. Okay, if not, the interference cannot occur. Okay, what is the name given to the source which has the same frequency and same phase difference? So this one we call it as the 2 coherent source. Okay, so this is the example of interference. This one also you already see the animation. Okay, so the interference pattern of water which is observed through a stroboscope. So what is the function of the stroboscope? So usually we use a stroboscope to freeze the motion. Okay, so for this one is to freeze the wave pattern. Okay, so let's say if you see the use your fan, right? Your fan, okay, when it rotates, okay, you can use the stroboscope. okay, to freeze up, okay, to freeze up the motion of the fan. So you can see the fan move slowly like that, or you can maybe just freeze, okay, you can just freeze the motion of the fan, right? When it still rotate, you can freeze it, okay? So this we call it as a stroboscope. So that's the function. Okay, so for this one we use in the water wave, because you can see in the experiment before, right, in the video before, the wave is keep moving, so it's hard for you to measure the wavelength. All right, so that's why we use a stroboscope. All right, so the next one, mark and label on the diagram, okay, the diagram, the region, on the region there. So the constructive interference, okay, is actually at the green one. So that is the constructive interference, while the line that you see, that one is a destructive interference. Okay, what happened to the water at the region of constructive interference? This one we already compare, right? Just now, like for the water wave, for the sound wave, and also for the light wave. Okay, so for the water wave, at the place where the constructive interference happen, so the water will move up and down, right? The water will move up and down. But what happened at the water, okay, at the region of distraction, the water will be calm. Okay. All right. So for this one, they're able for you which is the constructive interference, okay, and which one is the destructive. Okay. So I just give the a few example. So let's say if I take for C this one, okay. So for C, this one is a throw meet with the throw, right? This one is the throw meet with the throw. So of course it's the constructive. Okay, so at D also there will be a constructive because this one crest meet with the crest. Okay, so let's say if I take at point A here. Okay, so at point A here is actually crest meet with the throw. So at point A, this one is a destructive. Okay, B also is the destructive because the crest meet with the throat. So destructive also. Okay, so that is how you want to make sure, right, which one is a constructive interference, which point is a constructive, and which one is a destructive. You have to see, okay, whether it's crest meet crest or crest meet throat or throat meet with the throat. Okay, we move on to the next one. Okay, so this one also already explained, antinodal and nodal line. Okay, do you have any question to ask for the interference before I move on? Any other questions? Can you understand what is actually interference? Okay. All right. So if you can understand, okay, so this one, this is actually to show the antinodal and nodal line. Okay. All right. So this is for you to answer. Okay, wait for a moment. All right. The question is, okay, okay, so I just give you, this is the crest. Okay, and the dotted line is the throat. Okay, so let's try to answer this one. Okay, so which point is a constructive and destructive interference? So there are point A, B, C, and D. Okay. Anyone has problem to submit the answer, you can just put the answer in the chat. Okay, Thompson, Yvonne, Ika, Viresh, Rachel. So remember, constructive crest meet with the crest or throw meet with the throw. Rachel, are you okay? All right. Okay, so let's discuss the answer here. So you can see at point A is the throw meet with the throw. So of course it's the constructive. Okay, B is the crest meet with the throw. This one is actually a destructive. Okay, and this one is the crest meet with the crest. So of course it's the constructive. And this one is the crest meet with the throw is actually destructive. Okay, at point D here. So A is constructive. B is destructive. While C is the constructive. And D is the destructive. So A and C is the constructive. Do you get what is B? What do you mean by B? Joey, BD is what? Then what happened at the B and D there? C is constructive. A is destructive. Are you sure? This is wrong, right? It's actually A and C is the constructive. B and D is the destructive. This one also wrong. Jai, what does it mean by B there? This one also wrong. Mickey, are you okay? Can you understand why the answer is A, C, and B, D for the constructive? Where is Mickey? Jayu? Wrong. Virish? B is not a constructive. Okay. B is a destructive. Okay, and C is a constructive. Rachel? Okay, so I want to call somebody. for a moment. Ziyin, can you understand why is a constructive, AC is a constructive, BD is a destructive?
Yes, teacher.
Okay. Yilim? Where is Yilim? Jayi? For those who got the question, the answer wrong, can you understand? Virish? Rachel? Can you understand why your the answer is constructive is AC while the destructive is okay? Wait for a moment. Mm. Mm. Okay, so for this one, I want you to mark X, okay, where the constructive interference, okay, occur, okay, by using this diagram. Okay, using this diagram below here, you have to show to me where does the constructive interference occur. Just mark X there. Okay, remember the dotted line is the throw and while the line is the crest. Okay. Convent, Chayu, Mickey, Viresh, Yilim, Zishan. Okay, Zishan, you okay? All right. So let's check your answer. Okay, so actually, constructive interference where is the crest meet with, sorry, when the crest meet with the crest. So this is the constructive interference. Okay, wait, I use another color. So this one is a constructive interference, or is a throw meet with the throw here. Okay, so this one is also the constructive interference here, where they overlap. For the destructive, right? So for the destructive, let's say this is the crest and this one is the throw. Okay, so here, okay, when they overlap here, this is the destructive. Right, so let's see your answer. Okay, correct. Yeah, very good. Yes. Actually, I think Ethan, the one that you mark is all is actually the destructive. Right. Because it's the crest meet with the throw. I want constructive, not destructive. Okay? So this one is wrong. Right? This one is the crest, this is the crest, and this is the throw. So when they meet each other, they become the destructive interference. Okay, very good. Okay. Okay, constructive. X. Silvan, this is a destructive, right? This is the crest made with the throw. Okay, Silvan. Okay. All right. Um, Kenya, this one is destructive, right? Crest meet with the throw. Okay, so this is the crest, this is the throw. So when they met, they produce a destructive. Okay, so this one is wrong. Qing Yang. I say my X is at the wave, not here. This is actually X in the formula. Okay. All right. Um. Jayi, for this one, the one that you put X here, this one is a destructive. Okay, B is correct. This one is the crest made with the throat. They produce the destructive interference. I want constructive. Okay, 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 okay. Who is it? Tong Zuen. Long Tong Zuen, right? This is a destructive. This is the crest, right? The line here is the crest, while the dotted line is the throw. So crest mid throw is actually destructive. Okay, so this one is correct. Now, Viresh, the one that you put X here, this one is a destructive because crest meet with the throw here. So this one is a destructive. Okay, this is wrong. Are you okay, Viresh? Yeah, okay. Mm. All right. Okay, so we move on to the next one. Okay, actually the diagram that you use to mark the X is that is the formula. That is actually to describe a formula. Okay, let me erase this first. All right, so in the interference, okay, there is a one formula that you can use, okay, to measure the lambda or the wavelength, or you can measure the A, okay. A is actually the distance between two sources, okay, and X is the distance between two successive constructive or two successive destructive interference, and D is the distance between the source to the where you measure the X, right? So this is the formula. Lambda is equals to AX over D. So lambda is what? Lambda is actually the wavelength. Okay, the wavelength of the water wave. Okay, so example here. So this one is crest to crest. We call it as a one lambda. Okay, one wavelength. Or you can take from here to here. Okay, so any part of the wave, okay, that you can measure the wavelength, whether it's crest to crest or throw to throw, so that is the wavelength. And then another one is A. Okay, so A is actually the distance here. Okay, this is the A, the distance between two source of water wave, right? So this is A. And D is actually the distance from the source, okay, from the source to where you measure the X. So let's say you measure the X here, okay, there's line here. So you measure all the X here. So means the distance between the source to where you measure the X, that is called D, okay. And another one is the X, okay, it's the distance between two successive anti-node line or nodal line. Okay, so remember anti-node line is actually where you connected all the constructive interference, while the node line is where you connected all the destructive interference. Okay, so from the anti-node line to another anti-node line, so let's say the red one to the red one, so this is called as X. Okay, while the blue one is the nodal line, right? So sorry, the blue one is the anti-nodal line. So anti-nodal line to another anti-nodal line, we call it as X2. Okay, so they must take from the constructive to the constructive or destructive to the destructive, right? So that is the X. Okay, so this one is the destructive interference. Okay, they call as a nodal line. Okay, and the another nodal line, so this is called as X. And the one is from the antinodal line to another antinodal line. Okay, so that is called as X2. Okay, it's up to you if you want to take from the antinode line to another antinode line, or to the nodal line to another nodal line. So it's up to you. Okay, so this one is okay. So this is actually to show you about the constructive line. Constructive interference. Okay, so this one is a superposition. Okay. All right, so the next one we have to see what's the factor that affecting the interference of pattern. So usually when they come to us to when they ask to you about the factors, so you just have to refer back to the formula. So the formula is a lambda is actually equals to AX over D. So means all these all these four variables, okay, is the factor that affecting the interference pattern, right? So let's see the first one. So the first one is we use a distance, okay? We use this distance as the factor. So how does A will affect X, right? Because X is actually will determine how does the interference, okay, pattern. Okay, so the distance between two coherent sources A, right? So Okay, this is the diagram. Where's the diagram? Right. So I just show here. Okay, so the distance between two coherent sources. So how does A will affect X? Okay, so the first one, you have to compare the distance A and B. So A, you can see A here is much further, right? So mean A is higher than B. Okay, then we just see what is the compare the distance X. All right. So here you can see X, okay, from X from diagram B is higher than X in diagram A. So AB is higher than A. Okay, then what is the relationship between A and X? So you can see when they use a small x, okay, the X also will become, if you use the higher X here, so this one is much higher than this one, right? So when they use the higher A here, the X will become smaller. If they use the smaller A here, the X will become higher. So this is the relationship that is inversely proportional. Okay, inversely proportional. You just see here when they use the higher A, they produce the smaller X. But when they produce the smaller A, they produce the higher X. So this one is inversely proportional. Okay, and the next one, you have to state two physical quantity that needs to be fixed to ensure the top of relationship is correct. So in the diagram, we use A and X, right? So we have a formula, lambda is equals to, okay, lambda is equals to AX over D. So in this question, they use A and X. Okay, so you cannot use A and X anymore. So what you can use is the lambda and also D. So this one you need to fix, okay, if you want to measure the relationship between A and X. Okay, so lambda and D. Then you have to draw graph X against A. Okay, so for graph X against A, you already mentioned that A is the inversely proportional. So this is the graph for the inversely proportional. So remember, it's actually usually when they ask you to draw the graph, okay, so the graph should be y-axis against x-axis. Okay, so y-axis against x-axis. So y should be the x, okay, and A should be the x here, okay, x-axis. So y-axis is the x, y-x-axis is the A. So remember, must be y against x. Okay, so that is for distance. How does the distance will affect the x here? Okay, the next one we see how does the wavelength, okay, how does the wavelength, okay, will affect the value of x. So the first one, we have to compare the wavelength. So as you can see here, the wavelength for A, right? So wavelength is, let's say, from here to here. So this is one wavelength. And this is one wavelength. So of course, the diagram A has the higher wavelength. Okay, how about the frequency? Okay, so for the frequency, if you want to compare, we use the formula here. Lambda is equals to VF. Okay, this is actually come from V is equals to F lambda. Okay, so in the diagram, they already show you, right, the lambda, let's say I'm using 1.5.9A, right? So the lambda here is higher. Okay, then what will happen to the frequency? The frequency will be lower. So means here, the frequency of A is lower than B. Okay, because of the wavelength there. Okay, for B, you can see the wavelength is lower. So means the frequency is higher. Alright, so here if we compare the A, okay, A have the smaller frequency than B. So how does I know? I'm using the formula V is equals to F lambda, okay, to find the frequency, okay, based on the wavelength. Okay, and another one, you compare the distance X. Okay, so this one you can use the diagram. So the diagram A is higher than B. And how relationship between lambda and F? Okay, so lambda and F, you can see here, right? This is inversely proportional. Okay, can use the formula too, right? So when the lambda increase, the frequency decrease like that. So this one is the inversely proportional. And what is the relationship between lambda and x? So if you use the higher lambda or the higher wavelength, then you can see your x also is higher. If you use the smaller wavelength, your x also becomes smaller. So this one is the relationship is the directly proportional. Okay, and the next one, two physical quantities. So we use lambda is equal ax over d. So for this one, they find the relationship between lambda and x. How does the wavelength will affect the value of x? Okay, so it means here you cannot use lambda and x. So you use the a and d. So a and d must be the constant variable. Okay, so a and d. And this one, draw graph x against lambda. So remember y against x. So your y-axis should be x, while your x-axis should be lambda, and the graph is directly proportional. So that's how does the wavelength affect the interference. Okay, the next one, how does the distance, okay, the d, okay, will affect the x? Okay, this is actually come from this formula. Okay, they arranged back the formula to find the relationship between x and d. So based on the formula, you can see when x increase, d will also increase. So the answer is directly proportional. Okay, and what is the two other physical quantity that needs to be fixed? So this one, they use x and d. So the one that you need to fix is the wavelength and also the distance between two source of water wave. So a should be the x and a should be the constant variable. And this one, x against d. So since we already know directly proportional, so this is the graph. Okay, and this is actually the summarize. Okay, the relationship lambda is directly proportional. Okay, D is directly proportional and A is inversely proportional. This one is just the summarize from just now. Okay, now I want you to answer this one. Okay, you have to find the wavelength by using this formula. Okay, lambda is equal ax over d. So we already discussed what is a, what is x, and what is d.
Teacher,
Yes?
can you send the class code again because I accidentally logged out just now and then my computer, the whole tab went
Oh.
gone already.
Okay, okay. Never mind. Sorry, I didn't notice your text just now. Okay, because be careful with your X, okay? Okay, Ethan, Caroline. Okay, Karen, I'm sorry, make a problem. Okay. Oh, right. So many answers. Okay, never mind. Okay, lambda is equals to AX over D. Okay. So here it means they ask you what is the wavelength, right? So mean they ask you to find lambda here. Okay, so what is A? Okay, remember A is actually the distance between two sources of water. So means A is 4 here, right? This is the source of the wave. And then X, for X, remember, it should be like from antinode to node, antinode to another antinode, or node to another node, right? So for this one, they use the antinode. Okay, so you can see there are two antinode here. There are two X here. So each one is actually X. This is X and also this is X. So 2X is actually equals to 16. So 8X is actually equals to 8. Okay, and for D is actually distance from the source, okay, and where you measure the X. So D is a 20 cm. So then you just use the formula. A is 4, X is 8, and 20. D is 20, 32, you get 1.6 cm. Maybe for those, I think you got 3.2. You didn't divide with 2 first, right? Okay, very good. Then how you get 6.4? Oops. Tuition, how you get 5? Ratio 1.6067. That's 1.6. Okay, for those who didn't get the answer here, who got wrong for the answer, can you understand how actually I got 1.6 cm? Any questions? Can you understand how does I get 1.6? Okay, for those who are wrong, especially for those who are wrong. Okay, next, this one you have to find X. Okay, be careful with the unit. All right, be careful with the unit. Because some of it, the unit is mm. Okay. Johnson, Ziying, Ziying. Dah. Alright, so let's check your answer. Okay, so this one use lambda is equals to ax over d. Okay, so here the lambda is from crest to crest. So here 30 mm is a lambda. Okay, but you can see the unit here is not same, right? So you have to change all the millimeter to meter. So for the prefix, okay, you already learned in form 1, milli is 10 power of negative 3. So actually the lambda is 30 times 10 power of negative 3. So that is the lambda. Okay, I changed to meter. And the next one is the A, right? So A already been given also. So 20 millimeter. So I change again to meter. So milli is negative 3, while D is actually 2 meters. So this one you don't need to change, already in meter. So what happened next is we have to use the formula, right? So 30 times 10 power of negative 3. Okay, A is 20 times 10 power of negative 3, then multiply by x, okay, then 2. Okay, and you just divide. Okay, 60 exponent negative 3. 60 exponent. Okay, divide by 20. So you got the x3. Okay. So let's check your answer. 3 meter. Okay, very good. Oh, wait for a moment. Okay, 3,000 meter, millimeter. 3,000 millimeter. You give the answer in millimeter. So 3, yeah, but you can usually when we change the value of prefix, okay, we change it to SI unit. Okay, you already know length is the SI unit is meter, right? So change it to meter. Okay, so next time make sure when you change the, let's say the unit is not same, right? So one is millimeter or one is centimeter and another one they give in meter. So you change it to meter. Okay. If the unit is not same, so means you change all the unit to SI unit of the length that is meter. Okay, so for this one is okay, but next time make sure you answer in the SI unit. 300 cm is actually 3 meter, yeah. Alright, so next time make sure it's in SI unit length, okay, it's in meter, not Teacher, I thought around the unit should be 3 meter, not 3 cm. Oh, okay. Okay. 12. How do you get 12? Oh, most of you got actually used the millimeter, is it? Remember, you have to change to this one. Written is in millimeter, is it? Zishan, 3000 millimeter is 3 cm. 1 mm is 10 cm, right? Maybe you change it wrongly. Okay, so this one is mm. Okay. Make sure let's say they give you a different unit. Okay, you change all it to SI unit. Okay, so for length you already know in meter, so all the millimeter have to change to meter, not the meter change to centimeter or millimeter. Alright. So if they give you different unit, all of it have to change to SI unit. So if they give you in length, so mean you have to change to meter. If they give you, let's say second, they give you another one, maybe microsecond, millisecond. So all the microsecond and the millisecond have to change to meter. Have to change to second, right? So you have to go back to the SI unit. Alright, so I think I will stop until now because interference of light is quite long. Okay, so I will stop until interference of water wave first. So let's say if you have any question, okay, you can just text me. So I will just stop the class now. So we continue on Thursday. Alright, so this is the last day of the presentation. So make sure you let's say you have a problem to present, you just can text me. Okay, and if you cannot present, okay, you just have to put your project, your PowerPoint, and also the video in the Google Drive. And I forgot to mention you, all the project will be take like 10% of it in your final year exam. Okay, for your project, okay, I will take like 10%, okay, from your project, okay, in your exam. So mean 90 marks come from the final exam, and another 10 marks is come from your project. Okay, so I see you on Thursday, right? So thank you everyone. Okay, welcome. Bye.